We're at Synthesized Festival in the Centre for Computing History in Cambridge and celebrating all the connections historically between computers and synthesizers. First of all, let's have a good look around this museum. It's awesome! One room was full of all kinds of vintage synthesizers. Loads of fun to be had there. Then in the main hall of the museum there were a few of us showing off some of the projects we've been working on. This is the hack setup, and I'd advise from this point that you turn on the subtitles because there's loads of ambient noise. There is everything set up. I think it's looking pretty good. Let me take you through everything here. I mean, everything is being clocked off of the paper tape here. This is the master clock. If I turn up speed here and turn up the mixer, and this 5-hole paper tape, this was originally used for teletype messages as a way to store the messages before you had things like floppy disks, and of course later on was used to input information and program early computers. And off this tape we're reading voltages, so we can send that to the pitch control of our voltage controlled oscillator. So the voltage off this tape is coming down into this case, and that's controlling the VCO. You can fiddle around with the envelope generators and stuff. Also, off of the tape, we're not only reading CV for pitch, we're also reading drum patterns. This is just a computer code tape, it's not really actually musical, so you're just going to hear some pretty random drums. Well, there you go, you get the idea, but if you had a musical tape, you could do drum patterns on it. Up here is the kind of Alan Turing section, so we've got the Music Thing modular Turing machine made by Tom Whitwell, and this is inspired by Alan's theoretical idea of how to make a universal computing machine, an automatic machine. In that concept it had an endless tape, and that's kind of emulated by this shift register here where the bits are looping around and you can get a random sequence and then loop it around. There we got the Computer's filter here, sounding great. And the beat boop envelope follower, which I'm using as an envelope generator. And that's all clocked off the tape, of course, remember, and those CV signals are going through the Enigma lamp board, because of course Alan Turing, probably most famous for his work breaking the Enigma codes at Bletchley Park. So that's the Alan Turing section. And also here we've got one of my clicky relay modules, and if I switch this into low frequency mode, that's clocking this relay here, and that is switching the CRT screen. There's Gene Kranz. We're watching Apollo 13 on the VHS. Some glitchy graphics, some more blurb down here about relays and their role in old computing and doing mathematical stuff with the logic switching, and we've got one of the switches, and the case came off this relay, but it looks really cool. I'm going to keep it like this. Look at that, awesome. We've got of course the mechanical GIF with the relays switching in that, and talking on this blurb about the Harwell Decatron computer at Bletchley Park, the oldest working computer that used relays and Decatrons. A bit about old computing there, linked in with music. This is what we're all about here. We've got the modern logic, wow, I say modern, but not so modern, CMOS chips, and then the quad 2 input logic gates here, and that is duplicating all the clock information and the drum triggers. So the Prophet 6 here is going through a MIDI to CV converter, going into the telegraph lamp board. So we're playing the notes here, and it's getting translated into telegraph code. And if I find the figure shift, where is it? There it is. And then we can do ding in the bell. Of course, new addition. Figured out the Disky panel, looking cool. Of course, we're at a computer festival, so celebrating the Apollo Guidance computer. First to use silicon ICs. Over this side we've got the Uniselector sequencer, which is all being clocked, of course, off of the paper tape. And you can do its internal clock with the interrupter setting. It's got a Uniselector here, mechanical switch, which was from a telephone exchange and now turned into a musical sequencer. And if I turn the sound on, Uniselectors and other electromechanical devices, of course, were very important in early computers. Uniselectors were used in Colossus that we did a video about before. We had the Echoplex delay running, but the tape has got all chewed up, so I did predict that happening, so I brought some guitar pedals with us. We're using the delay here on a few things, auxing it out of the board. So now, we should be able to play it all together. It might even sound somewhat musical. We shall see. This is Newcombe Computer's SWTPC, a 45-year-old computer that he's modded to play synthesizers. And I could never do a video as good as him, so the link to his video is up in the corner and in the description. John's going to tell us about what he's brought to the exhibition.
Okay, thanks Mitch. This is a 1979 NASCOM 2, which is using its parallel port to connect to a homebrew MIDI interface. And that MIDI interface is talking to a sound module here. The software is kind of dodgy software written by me to play MIDI files, and it's really just an excuse to bring a NASCOM to one of these events, which is, in this case, all about music. The aim really for me is to get a NASCOM to every single event that the Computer Museum does. and so,
I know you love them. I've watched your videos on YouTube about them, yeah.
Yeah, this is the musical version of a NASCOM. We're just loading up a bit of music here. It's loading from cassette, albeit an electronic version of a cassette.
Oh, great.
It would have been using disc, but the disc unit uses the same port as the MIDI interface, and I haven't had time to sort that bit out. So, okay, here we go. So let's run this.
Okay.
I've not tried this one, so. I've got a font on the screen here. I'll just
That's fantastic. Sheila, do you want to show us what you've brought to the festival?
I brought MIDISID with me today. It contains two SID chips, which is the sound chip from a Commodore 64. This is, makes the sound from simple waves.
Yeah.
So where this started, I wanted to use my Commodore 64 for playing music live and to hear the sound of the SID chips, which I did achieve using a MIDI cartridge. this is the software that I'd written. But that's all very clumsy by the time you get out the 64-volt power supply. And I decided to try and shrink this down into a device that would give me control of the parameters, as well as being small and portable and low power.
Really nicely packaged.
So this is what we have. Two, in fact, they're SID replacements. These aren't genuine SIDs, and I wouldn't want anyone to use real SID chips.
Yeah, maybe they belong in the Commodore 64.
In a device like this, they should be in real Commodore 64. So we've got modern SID replacements in there, two of which give us 6 voices. So it receives MIDI and distributes the notes among the voices. 6 voices give us 6-note polyphony.
Oh yeah, that's a very familiar sound.
The SID chip is very versatile. It has different waveforms, filter, all sorts of features. I've built in some presets here, so if we go through them, you can hear the variety of...
A lot of sounds out of one chip.
An alternative way to play this is to use the voices combined together to give you even more funky effects. The trade-off is that you then have single note polyphony.
That sounds great. Portamento.
These are presets, but using the menu we can go in
make your own ones, right?
into the parameters. And,
so what do you have control over in the parameters there?
So starting with the waveforms, the SID has 4 different waveforms.
Oh great, it's actually displayed the picture.
Triangle, sawtooth, square and noise, percussion and sound effects. But then you can combine those for a wider range of sounds. The SID chip does an envelope as well, using 4 controls here.
I love the user interface.
Pulse width and pulse modulation, and then the filter.
You need every synth needs a low pass filter. Very nice. And these are clicky encoders.
Yes, I'm using push button encoders just to try and give you the maximum sort of control. So there's a bunch of other stuff, vibratos, filter sweep and so on built in. So in general MIDI mode, we can send in more complex MIDI in the form of a .mid file or something like Compose that uses say 6 channels, and MIDISID will do its best to render that using the 6 voices it's got on the 2 SID chips.
This is what getting on a DOS machine is like. The machine is now crashed.
This is a theremin basically.
Yes, it's theremin light.
Okay.
It works in a very similar way to a theremin with a volume control and a pitch control on the 2 bands. And there's a certain amount of configurability that will allow you to change the way that works. But it's very similar to a traditional theremin.
So if you press the launch button while the chord's in play, that's the same as nudging the table. And if you nudge the table too hard,
So that's audio mode. e-ther is generating a sine wave there and sending it out via an audio module. It'll also send MIDI out over USB or traditional MIDI, in this case over TRS, which you can easily convert to good old-fashioned MIDI.
Plug that to control the SID chips.
So here I'm using this as a controller. I'm using the sounds that MIDISID is generating.
Oh yeah, that's a good one. Where can people find out more about this or get hold of one?
Peacock Media Software.
Peacock Media Software.
Peacockmedia.software.
Oh yeah. Thank you very much, Sheila.
So my name's Jonathan Pallant, and I'm here with the Centre for Computing History with a little slice of the 1990s.
Look at that.
So we've got a Pentium 3 running Windows 98. We have this delightfully terrible Commodore branded MIDI keyboard, and then this is the software that came with the keyboard. The interesting thing about the setup I've got here is we can listen to the audio in a number of different ways. So, classic PC audio was with the Ad-Lib sound card or the early Sound Blaster sound cards. And I can go into my settings and I can choose Creative Music Synth, and that means we're now using the Ad-Lib or the Sound Blaster audio. So the piano is not a great piano sound, and then if we turn on the rhythm section, it's sort of that classic DOS gaming. And this is what most people had available. This was sort of
it's a very familiar sound.
It's a step up from the PC speaker, but yeah, the Yamaha FM synthesis chip that those cards use has a very, very distinctive sound. But then a couple of different things changed in PC music. Roland produced the MT32, a MIDI module that could generate high quality sounds. I can't afford one, so this is a Raspberry Pi running the MT32 Pi software. So it's emulating a Roland MT32, but we can go into the settings and we can use that as our output device. And now, there we go, so we get a Roland piano sound and we turn on the full drum section.
Now we're jamming.
But you hear that sort of that bell sound in the background. That's because the Roland device isn't general MIDI. So the patches are not in the right place. And this software is set up for general MIDI. So it's trying to play, I think, like an acoustic bass, but instead you're getting weird bell sounds.
Okay. Still sounds good. I think it works.
It's a pretty good synthesizer, but then because this is actually a Sound Blaster or 64, we can also use the built-in EMU 8000 wavetable synthesizer. I've been listening to these sort of side by side. It's really interesting the difference in the drum kits and the way they generate what should be the same sounds, but you get quite a different feedback. So the Sound Blaster Raw 32 introduced this hardware wavetable synthesizer, and the AW64 had pretty much the same chip. But what Creative added with the AW64 was the final option we have here, which is WaveSynth WG. What happens here is PCs are finally fast enough to do the sampling, the wavetable synthesis themselves. So you don't need hardware in your sound card.
Right.
The processor can do it. So with the Pentium 3, you can use this synthesizer. It sounds a bit different, but as good. It doesn't use any hardware features on the sound card. This is just straight CD audio out the back. We're not using the DSP. Right. And after about 1998, this is what all PC audio was about. It was all done on the processor, and there was nothing really for the sound card to do. So after about 1998, as long as it's 16-bit stereo, all sound cards work pretty much the same. You get slightly better quality, slightly worse quality, but the days of needing a specific card to play a specific game and getting a specific sound out of it consigned to history.
So we've just taken a step through time, seeing all the progression.
You've been through a decade and a half really of PC audio.
Amazing.
So the Roland was I think about 87, the Ad-Lib was around then as well, the AW64 was mid-90s, and then sort of late 90s you get to the software synthesizers. And now it's all
today.
Now it's all VST plugins and that's how it works.
Amazing. Thank you very much for that. Cheers.
Pleasure.
It's the end of a great day here at Synthesized Festival. Here in my natural element with the teleprinters. And if you want to see some of the setup that we had today and some other secret stuff that's coming, you can come to Machina, put on by the good folks of Elevator Sound in Bristol. That's in September, so come along to that and check it out.